So in part 2 video, now we are looking into how we can do data collection inside the manual. I have selected exercise number 3, influence of flow rate on heat transfer and calculation of Reynolds number. So we'll go to page 44 to see more details. Now in here, page 44, we have the objective and procedure. We have data collection table, and there is another table for calculated values. So we need, for every test we need to capture data twice. One is for the measured data and one is for the calculated data. Let's see what parameter we are changing here. Flow rate, because the experiment objective is influence of flow rate on heat transfer. So we will vary the flow rate and we'll see how the heat transfer is affected. So randomly you need to select any value for T16 initially as the input condition, and we'll keep changing these and we'll capture the data. So go to the software screen and I'll start the software. Right now it is at 52.9 and all the sensors can be identified from the schematic here. T16 water temperature in the tank, T1 inlet water temperature, T2 exit water temperature, T3 air inlet temperature, T4 air exit temperature, air velocity SV1, and you have SC1 water flow rate. Now AVE1 is a control for the fan, maximum speed, and you have the velocity here 5.2, and AB1 is the pump control, full speed, and you have the flow rate here 2.9 or 3 liters per minute. SC2 is not applicable here, it will always be 0. It's on the other setup, SC2 reading will be applicable, but for radiator this will always be 0. And T1, 2, 3, 4 can be measured from here, and when you click on calculation tab you have the other calculated values: Q hot, Q cold, Q loss, log mean temperature difference, heat transfer coefficient, Reynolds number for the hot fluid. So all of these calculated and measured need to be done for 4 different tests where we are going to change the flow rate. So let's see at 3. Once we select 3, this is at 3 and there is no air velocity, so I need to start the fan, operate it at full speed, and then I will wait for 3 minutes and I will capture. The waiting time is 3 minutes, or the run time is 3 minutes. For every experiment we want to give it some time for heat exchange, and this can be selected like 5 minutes or 10 or 15. So we have to decide on the time how much we will give to the system to exchange heat. So let's select 3 minutes, and then the hot fluid moves in there, the cold fluid moves in there, and they are exchanging heat for 3 minutes at that particular flow rate. So with that first condition achieved, 3, and the hot fluid is going in there, and this is also on position, the cold fluid is also going in there. We wait for 3 minutes and we capture the measured data, then click this capture the calculated data, after which we need to go to the next test, T2, to achieve this flow rate 2.5. I'm going to adjust this so that's the controller for the pump, so I am going to decrease the pump speed so the flow rate comes to around 2.5, maybe 2.4, 2.6. These are all acceptable because sometimes it's very difficult to achieve the exact number. So I will run it at 2.4 liter per minute, and again the waiting time, or the time for heat exchange, I take it as 3 minutes. So the timer starts now, I wait for 3 minutes, after which I will capture the measured data and calculated data. Similarly, I will go to the next test and I will do these settings, flow rate 2 and 1.5, and I capture the measured data and calculated data. So let's go here, and then from here I will decrease the pump speed so I reach a flow rate of 2, and then I start the timer. I wait for 3 minutes for the fluids to flow inside the exchanger and exchange heat, after which I will capture the measured data and calculated data. So that is all about the data collection and calculation related to the experimental setup on radiator heat exchanger.